Hi everyone. This is an example of what we call a mass to mole style of stoichiometry problem. Here we go. Determine the number of moles of nitric acid required to completely react with 12.8 grams of solid magnesium hydroxide. We've said it so many times already, we're looking for key words to help us wrap our head around what the reaction's going to be. This time, we have only the one phrase, reacts with. We can focus on that. Nitric acid is going to react with magnesium hydroxide. We need to do what we need to do to wrap our head around what the reaction is going to be. Sometimes we can skip the numbers when we read a problem, and there's only one, it doesn't really help. Let's say that again. Nitric acid react with magnesium hydroxide. Let's put that down. Nitric acid is an acid. Obviously, it has acid right in the name. If you don't know what it is, you can find it in the data booklet in the acid table. Nitric acid is HNO3. It's going to react with magnesium hydroxide. Magnesium is a 2+, hydroxide is a 1-. No mention of a precipitate. I don't care about the states. We have a double replacement reaction, the cation switch. The magnesium, which is a 2+, is going to get together with the nitrate, a 1-. And the hydrogen is a 1+, the hydroxide a 1-. We could write that as H2O if we like, or maybe it's easier to keep it as HOH. Now let's balance this reaction. Put those 2's in there. We end up with 2 hydrogens on either side, 2 nitrates on either side, 1 magnesium on either side, and 2 hydroxides on either side. Let's continue on. We have 12.8 grams of solid magnesium hydroxide. 12.8 grams, that's the mass. I'm putting M for the mass. It's 12.8 grams. It's 12.8 grams of magnesium hydroxide, so I'm writing it right underneath that chemical. That's what's given to me in the question. What am I looking for? Determine the number of moles. Find the moles of nitric acid. This is the nitric acid. The question says, let's find the moles. N? Question mark? We don't know what it is. This is what we're looking for. It's the R. We need to take our time. Our first step in any stoichiometry problem is to balance the equation, interpret the question. For sure, we have to write down the balanced chemical reaction. These extra labels are just very helpful. Maybe you're labeling them in your mind, just mentally labeling what's going on. However, writing them down can really help organize your work. Now, the second step is find moles. Can we find moles by reading? This only has 12.8 grams, so we need to do mass over molar mass. We have 12.8 grams of magnesium hydroxide, so we need the molar mass of magnesium hydroxide. We're going to do 12.8 grams. This is over the molar mass of magnesium hydroxide. That's 1 magnesium at 24.31 and 2 oxygens at 16 each and 2 hydrogens at 1.01 each. The molar mass of MgOH in brackets 2 is 58.33 grams per mole. After we find the moles, we're going to multiply by R over G. This is where this labeling makes it helpful. R, we have a 2, G balanced with a 1, times 2 over 1. We're looking for the moles. Our final step says solve. If you're looking for moles, if you're looking for N, stop. So here, we're going to stop. We have this calculation, 12.8 over 58.33 times 2 over 1. That's 0.438882222. We need to think about the significant digits. There's only one number in the question, 12.8. That's 3 sig digs. .439. This rounds up, and we found the moles. As we do more and more problems, we're going to get more efficient, which means we're going to get faster. Our confidence is going to go up with balancing equations, writing out reactions, and also with the interpretation. So far, our next step, no matter what, is going to be find moles. We've encountered 2 options so far. Sometimes a question straight up going to tell us the moles. However, sometimes if we have the mass given to us, like we did here, we must do mass over molar mass. The mass was of this chemical, so we use the molar mass of that same chemical. R over G works the same way all of the time. Whatever you're looking for, whatever's balanced up there is the R, 2 over 1. Whenever we are asked for the moles, we stop right after our mole ratio. Again, we can't forget about our significant digits. Watch that rounding, and don't forget those units. I hope that helps.